Hello, here's another AQA A-level physics question. This one's on circular motion. If you want to try to answer this question yourself, pause the video now. If you've got the answer D, well done. So a bob of mass 0.5 kilograms is suspended from the end of a piece of string 0.45 meters long. The bob is rotated in a vertical circle at a constant rate of 120 revolutions per minute. What is the tension on the string when the bob is at the bottom of the circle? Well, the tension is going to be on the string in that direction, and the other force on this bob is going to be the weight, mass times gravitational field strength of the bob. Now there'll be a resultant force acting upwards. We could call that just the force resultant, and that's going to be equal to the tension less the weight of the bob. And that resultant force is going to produce the centripetal force. So that resultant force is equal to, as I said, the tension minus the weight, but it's also going to be equal to the centripetal force, which from your data sheets is given by the mass multiplied by the angular velocity squared multiplied by the radius. Now if I could just find out the angular velocity, then I could use this equation to find the tension. So I know that angular velocity is equal to 2 pi multiplied by the frequency. So what is the frequency in this case? Well, it's 120 revolutions per minute. I need to know how many per second. So the frequency is going to be 120 over 60 seconds. It's going to be 2 hertz. So the angular velocity is going to be equal to 2 pi multiplied by 2. The angular velocity is 4 pi radians per second. Now I've got everything I need to put into this equation. Let's just write that equation out, making tension the subject. So the tension is equal to the mass multiplied by the angular velocity squared multiplied by the radius plus the mass multiplied by the gravitational field strength. So the tension is going to be equal to, we've got a mass of 0.5 kilograms. We've just calculated the angular velocity at 4 pi radians per second. We've got a radius is going to be the length of the piece of string, which is 0.45 meters, and onto that we need to add the mass and the gravitational field strength multiplied. So 0.5 multiplied by 9.81. Okay, you put all that into your calculator and you will get an answer of 40 newtons. I hope that was useful. If it was, share, hit the subscribe button, and watch more of them in the series. Thank you very much for watching.